You can push a 100-pound slab of solid material out of your way with a simple flick of the wrist. We do this every morning without thinking about it. We are moving massive weights, completely blind to the intense, colliding physical forces operating just a few millimeters out of sight. A sleek sliding wardrobe presents as a simple, flat piece of timber rolling along a basic set of plastic wheels. Erasing the massive friction and weight of that panel requires specialized engineering that functions specifically to hide its own effort from your awareness. Every sliding system negotiates the paradox of access. Because doors exist on parallel tracks, opening one side completely eclipses the other. This creates a permanent dead zone. You gain floor space, but sacrifice viewing the entire interior at once. Moving these heavy planes follows a mechanical logic that avoids the floor-based friction of a train on steel rails. Most heavy-duty wardrobes utilize a top-hung mechanism, suspending the entire mass of the panel from the cabinet ceiling. This means the track on the floor supports absolutely zero weight. It acts purely as a directional guide to keep the door from swinging outward. To remove friction from our morning routines, we abandon ground-based support and suspend industrial-scale loads directly above our heads. Some systems rely on a bottom rolling track, but if placed directly on the bedroom carpet, the constant compression of the fibers causes the entire mechanical system to warp and eventually fail. Installers must insert a specialized floor packer, a rigid base layer creating a perfectly level foundation so the track won't sink under a shifting load. The structural demands are even more extreme for pocket doors, often thought of as panels that simply slip into pre-existing empty voids inside your walls. Creating that pocket requires invasive surgery to embed a heavy-gauge steel cage into the wooden framing. The physical load paths of the house must be rerouted around this compartment. You permanently alter the room's structural makeup just to hide a panel. And the materials being hidden are incredibly dense. A single pane of sliding architectural glass can weigh upwards of 120 kilograms. Achieving a clean, airy aesthetic necessitates destructive architectural surgery and the deployment of heavy industrial-grade hardware right inside the bedroom. Even with hidden hardware, traditional sliding doors have a visible flaw. Running on parallel tracks, they sit on staggered depth planes, creating a noticeable overlap. To fix this, engineers developed coplanar systems. When closed, the doors sit perfectly flush on the exact same plane, forming a single unbroken wall. Opening a coplanar door requires a complex two-step motion. The mechanism must physically step the door outward on the Z-axis, clearing the adjacent panel, before allowing it to slide sideways on the X-axis. For entirely handleless designs, a push-to-open feature is integrated. Pushing inward triggers a kinetic spring that violently ejects the door sideways to start its glide. But getting a heavy door moving creates a serious problem with momentum. You must stop that fast-moving mass without causing a collision or cracking the frame. Simple rubber bumpers or standard coil springs simply cannot handle this kinetic energy. Instead, hydraulic dampers engage the door as it nears the frame, using fluid resistance within a cylinder to catch and decelerate the mass without rebounding. Domestic tranquility is maintained by adapting the exact same fluid dynamic braking systems used to slow down heavy machinery and aerospace vehicles. Yet, even coplanar systems suffer from the zero-sum paradox of access. To finally bypass the problem of overlapping doors entirely, engineers developed the compass movement. This hybrid setup combines different mechanical logic. The panels glide along a smooth top track, but as they move, they simultaneously hinge and fold outward, stacking neatly at the edge of the frame to expose the entire interior. Thick fluid surging through microvalves, steel cages bearing thousands of pounds of tension, massive sheets of glass hovering fractions of an inch off the floor. Modern architectural engineering actively and completely erases its own mechanical footprint from our daily awareness. Our built environment relies on these hidden structural feats. Every morning, we clear paths through heavy industrial materials with a single touch, completely unaware of the mechanical miracles making it possible.